Behind everyday products used by millions of people worldwide lies a vast industrial operation where precision. Inside this facility, raw materials move through a carefully controlled system of machines and processes.
The layer on this one seems a bit thin near the edges.
Yes, we might need to adjust the submersion time on the next cycle. The viscosity is stable. We should hit the target thickness perfectly this cycle. Confirmed. The readings look
Check the temperature on line 3.
It seems stable within the parameters.
We run these lines 24 hours a day, making sure the coating is absolutely uniform before it hits the ovens.
Water clarity is optimal, pH levels stable. We are ready for the drying phase.
Confirmed. Moving to stage 4. The integrity tests are holding at 99.8%.
Good. Keep a close eye on the pressure differential read. See that bubble at station 3. Noted. Recording as failed.
The tensile strength on the new alloy is exceeding projections by 15%.
That aligns with the subcycling results. We can.
The viscosity levels are stable, but we should check the pressure on the applicators.
I agree. Let's run a calibration test before the next.
The pressure on the nozzle seems low right here. Yeah, the readings confirmed it. We need to adjust the flow rate.
cooling zone utilizes high-velocity air streams to quickly set the latex on the glass molds.
The temperature on zone 3 is consistent.
Noted.
The stabilization looks good on this batch.
Keep an eye on the flow rate over here. Look steady, make sure the temp stays below 25.
The washing stages are critical to ensure product hygiene before the final curing process.
The washing cycle begins as the heavy drum door seals. Motorized valves open, allowing
Inside the rinsing section, the mass tumbles vigorously, ensuring all surface chemicals are removed before the final step.
Inside the thermal processing area, hot air circulates to remove all moisture, ensuring the rubber becomes complete.
The air inflation test determines elasticity and strength. The sample must withstand high pressure before reaching its...
In the finishing stages, a precise drop of medical-grade silicone lubricant is applied to each rolled unit.
The integration of robotic arms and high-speed conveyor systems allows us to process thousands of units per hour with...
Get that pallet secure before the next truck arrives.
Copy that. Coming around the corner.
I need that pallet by the conveyor, stat. Copy that, moving it now.
Whole grain oats, 20% daily value, suitable for.
There you go. Have a nice day. Thanks, you too.
Documentation confirmed.
Clearance granted. Proceed.
The Black Emperor wine bottle is invincible.
Part 5. Logistics and Warehousing, Bectain.
For most people, an old car reaches the end of its life quietly. It is parked for the last time, left to rust, forgotten. But in the industrial world, nothing truly ends. Here, old cars do not disappear. They are dismantled, crushed, melted, and reborn, not as vehicles, but as the steel structures that move global trade. This is the hidden journey of millions of old cars, from destruction to steel to shipping containers stacked across the world's ports. The process begins with force. Hydraulic breakers strike through
The hydraulic
windshields.
press exerts tons of
Steel
pressure,
claws
reducing
rip
the vehicle
roofs
to scrap
away in a
in
single
seconds.
pull. Car bodies are lifted, dropped, crushed, and torn apart without hesitation. There is no sentiment here, only physics, pressure, and controlled violence. These machines do not destroy for spectacle. They destroy to reduce complexity, to turn a car, thousands of components, into raw material again. Once the initial destruction is complete, the vehicles enter a controlled industrial flow. Remaining fluids are drained, batteries are removed, hazardous materials are separated. What remains is metal. Steel frames, doors, panels, and structural parts are compacted into dense blocks, then fed into shredders powerful enough to tear automotive steel apart in seconds. Inside the shredding chamber, rotating drums grab and rip the metal aggressively. Sparks burst outward. The sound is violent but precise. The output is no longer a car, it is fragmented steel. From here, separation begins. Magnetic systems pull ferrous metals from the mixed stream. Non-ferrous materials fall away, diverted into different recycling paths. Only steel continues forward. This steel is not waste, it is feedstock. Collected, measured, and prepared, it moves into the furnace hall, where destruction gives way to transformation.
The electrical current surges, melting the metal at temperatures up to 3,000 degrees Fahrenheit.
Furnaces, steel scrap is melted at temperatures exceeding 1,600 degrees Celsius. Solid metal becomes liquid. Chemistry is controlled. Impurities are removed. This molten steel no longer remembers the shape it once had. It is cast into slabs, rolled under immense pressure, flattened into coils and sheets. At this stage, the steel is clean, uniform, and strong, ready for its next life. Not as a car, but as something built to carry the weight of global commerce. The steel coils arrive at the container factory. Overhead cranes lift them onto uncoilers. Steel strips feed into leveling machines that remove any residual stress. Flatness matters here. Precision matters. Computer-controlled cutters slice the steel into exact dimensions. Sidewalls, roofs, floors. Each panel is identical, interchangeable, standardized. Then comes corrugation. Massive rollers press wave patterns into the steel sheets, adding rigidity without adding weight. This geometry is not decorative, it is structural. Corrugated walls are stronger, they resist bending, they distribute load. Next, the frame is built. Corner posts, cross members, bottom rails. Robotic welding arms fuse steel components together with controlled precision. Every weld is repeatable, every joint identical. This frame is the skeleton of the container. Onto it, the corrugated walls are mounted, welded into place. Roof panels are lowered and sealed. At this moment, the container becomes recognizable. An empty steel box, but far from complete. Inside, floor beams are welded. Heavy-duty flooring panels are installed to handle forklifts, cargo, and concentrated loads. Doors are added last. Not simple doors, but reinforced steel systems with locking bars designed to hold under pressure. Every moving part is tested, opened, closed, locked. But building a container is not enough. it must prove itself. Each finished container enters a structural testing hall. Hydraulic systems apply vertical compression directly on the corner castings, simulating the weight of multiple containers stacked above it. The steel does not bend, it does not crack. Racking tests twist the container diagonally, forcing stress into the frame. Floor load tests simulate extreme cargo weight. Door tests push against sealed entrances. Instruments measure deflection down to millimeters. Only containers that pass every test receive certification. These standards exist for a reason, because once containers leave the factory, they will face forces far greater than anything inside these walls. With certification complete, the containers move into real-world handling
This facility
environments.
processes thousands of tons
Reach
of corrugated steel
stackers
every
lift
week,
them.
meticulously
Gantry
organized by
cranes
size and
stack
type
them.
before being shipped
4
out.
high, 6 high, sometimes more. Weight transfers through corner castings. Steel designed specifically to carry vertical loads. This is where the design proves itself. The container does not collapse. It does not deform. It was built for this.
The robotic arms are now active, applying a uniform coat of primer as the containers move through the pressurized booth.
$15.2
Noted. Looks good.
Here we see the pressurized water spray test. The lack of moisture inside confirms the integrity of the seal.
All right, lowering the spreader beam now. Confirm connection at corner posts.
Confirmed, all green. Proceed with the lift.
immense pressure is distributed evenly across the corner castings, demonstrating the stability of the stack with remarkably low vibration.
So the load test is officially passed.
Yes, everything is within tolerance.
As the weight transfers, the resonance is absorbed, stabilizing the structure at full height.
The steady transit of these containers highlights the massive scale of the coastal port, a critical transition point in the global supply chain.
At Night Falls, this logistics hub operates around the clock, a critical node in the global supply chain, moving thousands of containers every day.